lesson, we are going to review how to factor out a GCF so that when we go into more challenging factoring starting next class, we will at least have this skill kind of refreshed in our brains. So factoring out a GCF just means figuring out the largest number that divides evenly into each and every term. It can't just be a couple of them. It has to be something all the numbers are divisible by. For variables, it's the amount that the terms all share. So if something has an x cubed and something else has an x to the fifth, they both have at least 3 of them. Okay, so 3 would be the most I could bring out. So for variables, it actually ends up being the least amount. Once we factor out the GCF, we want to make sure that we are paying attention to the sign of the leading term to know if the GCF is positive or negative. So I'm going to start us off a little bit easy, looking at 6x to the 4th plus 8. I want to think about something that both 6 and 8 divide by. The largest number that both 6 and 8 divide nicely by is 2. Now, this is not an equation, so I don't actually have anywhere the 2 is moving. We're just bringing it out front. We're undistributing it. That's what factoring is, undistributing. So I have 2 out front, and then I'm going to divide each term. So 6x to the 4th divided by 2 would be 3x to the 4th. 8 divided by 2 is 4. I couldn't bring any x's out because the 8 didn't have any x's. So that's one option, to just write, I'm dividing all of this by 2. Your other option to do the exact same problem, if this is easier for you visually, you can say you're bringing 2 out of each of them. Okay? You're still bringing that shared 2 out front, and then dividing each term. So some people prefer to write it under each term just because it's easier to figure out what's left inside. So if I wanted to take that approach on this next problem, 24 and 16. The largest number those both divide by is 8. And then I have an x to the 5th versus an x squared. The only amount I could bring out of both of those groups is an x squared. So I have an 8x squared coming out front. For my first term that's left over, 24 divided by 8 is 3. I had an x to the 5th, so I had 5 x's on top, but I brought 2 out. So if I had 5 and I removed 2, that means I have x to the 3rd left. Again, I had 5, 2 of them came out. That leaves me with 3 and 7. Plus, for this next part, 16 divided by 8 is 2. For my x's, I had 2 on top. I brought 2 out front, so there are none left inside. Okay, essentially, we're subtracting our exponents. On our next one, I noticed that my front term is negative, whereas on my first two examples, the front term was positive. If your front term is negative, you automatically have to bring a negative number out. So I'm bringing negative something out. I look at 9 and 12. The biggest thing they both divide by is 3, so I'm bringing out a negative 3. I have an x cubed versus an x to the 1st. 1 is less, so that's the amount I can bring out. So I have a negative 3x coming out front. When I go to divide my first term, negative 9 divided by negative 3 is 3. X cubed, bringing an x out, leaves me with an x squared. For this back group, negative 12 divided by negative 3 is positive 4. And the only x already came out front. If you're ever unsure, you can always redistribute to check that you get your original problem. Next one, the only difference is that now I have 3 terms. So I need to think of something that 5, 40, and 10 all divide by. 5, 40, and 10 all divide by 5. My first term has an x squared. My second term has a single x. And my last term has no x's. So they don't share any x's in common because the last term doesn't have any x's. So all I can bring out is a 5. Okay, 5x squared divided by 5 is just 1x squared. Negative 40x divided by 5 is negative 8x. And then 10 divided by 5 is 2. When we move through this unit, we'll then have to check if that trinomial inside can factor. This one cannot, so this problem would be done. Okay, so we like to check for a GCF first because it might make our problem simpler. Okay, my next one, again, I notice I have a negative at the front, so I'm dividing by something negative. It's all about the first term. I have 12, 3, and 9. The largest thing all of those divide by is negative 3. I have an x to the third, x squared, x to the first. They all share at least one x, so that's what I'm bringing out. And it's always whatever your least amount of x's is. So in this case, that's just 1. Here it was none. Again, don't lose the GCF. Negative 3x is the GCF, greatest common factor, the greatest thing it can divide by. Negative 12 divided by negative 3 is 4. Now I'll have x squared left. 3 divided by negative 3 is negative 1. So if you want to put negative 1x, you can. If you prefer to just write minus x, that is fine as well. 9 divided by negative 3 is negative 3. Next one's a little bit harder just because the numbers are bigger, but again, I have a 63, a 49, and a 21. 21 is the smallest, so my only options are going to be either 1, 3, 7, or 21, because that's what 21 divides by. The largest thing all of these divide by is going to be 7. I have x to the 6th, x to the 5th, or just an x. I have to go with just a single x. So out front I have a 7x. When I divide, 63 divided by 7 is 9. X to the 5th minus 7, x to the 4th minus 3. I encourage you to try these last 6 on your own. If you want to do that, pause the video. When you're ready to check them, go ahead and hit play. The largest thing I can divide by here is 17x. Which leaves me 3x minus 1. The largest thing on the next one is going to be a negative 8c squared. Again, negative because my front term is negative, has nothing to do with the second term. When I divide, that'll leave me a 7, because I already brought the c squared out, minus 1c to the 7. Again, if you did not have the 1 there, that's okay. So if you just had 7 minus c to the 7, that would be okay. Next one, biggest thing for negative 16 and negative 24 is going to be negative 8. This one's a little trickier because we have multiple letters, so let's check the m's first. I have 5 versus 2. The most I can bring out is 2. For my n's, I have 3 or 4, so the most I can bring out is 3. So coming out front, I have negative 8, m squared, n cubed. When I divide, negative 16 divided by negative 8 is 2. brought 2 out, that leaves me with 3. I had 3 ends, they all went out. For the next part, negative 24 divided by negative 8 is 3. On this problem, all my m's came out, but I have an extra n left. Again, if you want to try these bottom 3, you can pause the video. I highly encourage it. The largest thing these two divide by is 11. J squared is the most j's I can bring out. K squared is the most k's I can bring out. So I have 11, j squared, k squared. And then you're just dividing each piece. 77 divided by 11 is 7. My j squareds cancel. I have k to the third left. Minus 44 divided by 11 is 4. J to the third, and this time the k's cancel. Next one, a little bit more straightforward. They both divide by a 10p, leaving me p squared plus 12. Last one has a lot going on. I see my front term is negative, so I know I can divide by negative. That's like a negative 1. The biggest I can divide by is negative 1. They share no x's, no y's, no w's, no z's. So all I can bring out is a negative. If you want to put negative 1, that's fine. Usually it would just say negative. And then I have x to the 7th y. 2 divided by negative 1 is negative 2 w. The first half of this next unit is all about factoring. It's really important we be able to factor out a GCF because it's the building block for all our other factors. Next class, we're going to start with our difference of squares special case. So you are done with this set of notes. Make sure you complete the delta math, which covers both radicals and factoring out a GCF. Make sure you do those before our first lesson on factoring.